Hi again, it's Jason from S.T.E.M Online, our online math and tutoring physics company. Okay, so we're going to start our very first problem, and we're going to look at mastering the concept of limits in AP/IB calculus. Okay, so let's look at the problem, right? So the question is, right? So line here's the question. Question: How do you evaluate? Do you evaluate the limit as x goes to 0 of sine 5x over x. This is sine 5x over x without L'Hopital's rule. Okay, so without L'Hopital. Out L'Hopital's rule. Okay, so for those of you in AP, either in AP or IB calculus, you're probably familiar with L'Hopital's rule, right? It can be used on any limit that when you test the x as x approaches a, such that if the denominator gives you an indeterminate form of a quotient function f of x over g of x, then it's just this, the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime, right, which is a of f prime of x over g prime of x, such that g of x cannot equal to 0, right? That's when L'Hopital's rule works. Okay. However, we can use that here, but because the x goes to 0, so we have a quotient function. So for L'Hopital's rule, if you have a quotient function, a function divided by another function, such that when you plug in your x approaches a, as x approaches a, into the denominator, it gives you an indeterminate form, right? Let's say infinity over infinity, 0 over 0, infinity over 0, any of those situations, as long as the function is a function divided by another function, you can use L'Hopital's rule. Here, we're not going to use that. Okay, so we're not using L'Hopital, right? So not using this, not using L'Hopital's rule. Okay, so how do we evaluate this function? Okay, right, so we want to evaluate. So the problem is, right? We want to evaluate the limit as x goes to 0 of sine 5x all over x. So if we input x approaches 0 into this function, you'll notice that we get an indeterminate form because the denominator will give you a 0, sine 5x over 0. And we can't have that, right? If you get that, your limit will be incorrect. So we actually need to verify if it actually is indeterminate, if it is something over 0, or if we can simplify it and decompose it and get the appropriate answer that is actually a number. Okay, so how are we going to do that? Well, the first thing is, right, is that you'll notice, right, I can rewrite this as the following. 1/5, right, 1/5 the limit, 1/5 of the limit as x approaches 0, okay, of sine 5x all over 5x, right, 5x x technica right here. This would be multiplied by 5. Okay. All right. So 5 times the limit as x approaches 0 sine 5x over 5x. Now, why is this the same expression as this? Well, if we look at this carefully, right, the 5 is a constant from the limit. I can bring it in, right? This is equivalent to saying the limit as x goes to 0 of 5 sine 5x all over 5x. Okay. All right. And then this would cancel, right? And you're left with sine 5x over x. That's why it's the same thing. Okay. So from here, what we can say is, right? I'll just erase this right now. We don't need that. What we can say here is that this is 5, right? 5 times, okay? 5 times 1. And the justification for this, right? Justification is that sine, one second, there's a formula, that the limit as theta approaches 0 of sine theta over theta is equal to 1, where in this case theta was chosen to be 5x. Okay, so my 5x is my theta here. Okay, and I noticed that sine theta, limit as theta approaches 0, sine theta over theta is 1. Substitute that in for this portion here, 5 times 1. Therefore, the limit, right, limit as x approaches 0, sine 5x, 5x over x is just equivalent to 5, and that's the answer. Okay. All right. So I hope you enjoyed this problem-solving session on limits. Hopefully this will encourage you to practice your own limits. And if you enjoyed this video, press the like and subscribe button. And if you're still having trouble with tricky limits and you're in calculus, AP, IB, or in first year university, you can contact us at www.stem1online.com. Thanks again for watching the video. See you next time.